Hello everyone. In this video I am going to tell you about how to use the leading term or the leading ratio of terms to find the end behavior of a polynomial or rational function. So I have four functions here, and what I'm going to do with them is first I'll find the leading term or the ratio of leading terms, and then I'll use that to describe what the y values of the function do as x goes to negative infinity, so on the far left side of the graph, moving further left, and then also what the y values of the function do as x goes to infinity. So that will be on the right side of the graph, moving further and further right. So for the first function here, we have f of x equals x minus 2 squared, x minus 2 cubed, 2x plus 5 squared. So to find the leading term, it's not going to be a ratio because it's not rational. So we'll just find the leading term. You're going to take the leading term from each parenthesis. So for this one, it's 2x, and for this one, it's x. And you do need to worry about getting the coefficient with it because that might change the sign. Okay, so leading term is going to be, we're just going to drop anything else in those parentheses that wasn't the leading term, and we'll be left with x cubed times 2x squared. So if you're still struggling with exponents a little bit, don't forget you can always revert back to just this is x times x times x times 2x times 2x. Okay, so you've got 5 x's being multiplied together, and then you've got 2 times 2 as well, so 4x to the 5th. Okay, so if you know what the graph, if you know what all your basic power function graphs look like, 4x to the 5th looks like this. So it's an odd one and it's positive. So odd degree always look kind of like that. And then since the coefficient is positive, it has not been flipped upside down. So as x gets larger over here, so x towards infinity, the y values are going up. And as x becomes large but negative over here, so as x goes to negative infinity, the y values are going down, and there's no limit to how far down or how far up they go. So on the right side here, y is going to go towards positive infinity, and I don't know why I'm writing it like backwards over here, but because somehow it's on the graph, I want to write it going to the, I want to write these arrows pointing left, even though that's not really a thing we do usually. Anyway, I'll show you the proper way to do it in a second. On the left side here, y is going to go to negative infinity because it's going down, and there's nothing. It just keeps going down. It goes down through the floor, it goes down through the ground, it goes down through the crust of the earth and out the other side and off into the universe. Never stops going further and further towards negative infinity. Okay, so really to properly answer the questions here, this was part A, final answer. And then for part B, we would say this would be the kind of correct, proper way of writing it. As x goes to infinity, y also goes to infinity. And then for part C, oh sorry, that was part C. So we should say as x goes to negative infinity, y goes to negative infinity. And then part C, I'm trying to skip ahead here. That's my ADHD coming out. As x goes to infinity, y goes to infinity. Okay, I think I've properly answered them all. Let's do the next one, which is g of x. So for number 2 here, g of x is another polynomial, and now I just want to make sure that you guys didn't forget how to do it even when it's not factored, that you remember what a leading term is, and you can find it in the factored form or the expanded form. So this is expanded, and we just grab the term that has the highest degree on it and take the coefficient with it as well, because if it's negative, that changes the behavior. So the leading term here is, we'll call it the LT, is negative 8x to the 4th. And so you need to know all your basic power function graphs and also what being negative does to it. So x to the 4th, normally it looks like kind of like a cup shape, but since it's negative, that means we've flipped it upside down. So it's going to be like this. Okay. So as we go towards the right on the x-axis, the y values are going down towards negative infinity. And as we go towards the left on the x-axis, the y values are going down as well towards negative infinity. Okay, so y is going towards negative infinity in both cases. So for part B and part C, they're both going to have the y values going to negative infinity. This will be very helpful when you guys take calculus and you do limits at infinity. That's basically what we're doing right now. Okay. And of course, not just for the purposes of passing a class, but I mean, if you in your later life are trying to, for example, optimize some function, you want to know like how much do I need to run these certain machines in my factory to get the most sales or whatever, you know, it's important to be able to check what your computer tells you and know whether it actually makes sense, because you know how these functions behave out at infinity, whereas your computer cannot conceive of infinity. So, all right, that's my little sales pitch for actually understanding your math problems. Okay, so we're number 3 here. Now we actually have some rational functions. Let me scroll this down a little bit. So h of x is 3x minus 4 over x squared plus 3x plus 5. So for the leading ratio of terms, or the ratio of leading terms, you're just going to take the leading term from the top and the bottom. So that's 3x. And this one is also, oh, it's 3x. That doesn't seem like something I would have done, but I like to make them harder than that usually. Oh well, I guess I did it. Okay, so the leading term here for part A then, or leading ratio of terms, is going to be leading ratio of terms, I guess, LRT, is going to be 3x over 3x. And as you guys know, that is just 1. Anything divided by itself is 1. So what does that mean? Just like with these ones up here, where we were looking at how this expression would behave as a function, what this means is this behaves like 1, the function 1. In other words, the function or the curve or the graph, whatever you want to call it, y equals 1. This behaves like y equals 1. As you go towards positive and negative infinity, towards the far left and the far right. So near the origin, it'll look, you know, like some weird rational function behavior. But as you zoom way off to the left and way off to the right, it's just going to look more and more like a horizontal line at y equals 1. Okay, so for part B and part C here, it's y goes towards 1. Okay, for number 4 here, so this one, I've got a bunch of cords preventing me from sliding this paper up. Okay, so for number 4, we have p of x, and now we have a factored top and bottom in our rational function, but we know how to deal with that. So again, we're just still taking leading terms out of each parenthesis, get the sign or the coefficient with it, because that does make a difference. And then do this in the top and the bottom, and then just keep those parts and simplify them together. So this is negative x times negative 4x. Make sure you keep the parentheses, otherwise you're going to think you're subtracting, and you're going to get a completely wrong answer because you're multiplying these two factors together. So negative x times negative 4x, the negatives are going to cancel each other out. Let's bring the 4 to the front. So this is going to be 4x squared over 8x. Yeah, this looks like more the type of hard simplification I would assign. So we have, remember, if you forget how to deal with this exponent stuff, this is just 4x times x. And then on the bottom, this is 4 times 2 times x. So I can cancel a 4 factor, and I can cancel an x factor, and I'm left with just x over 2. Okay, so what that means is this function acts like the line y equals x over 2 as x goes towards positive or negative infinity. So let me draw you like a very tiny little sketch here. There'll be some different behavior for small x values, but as we go off towards positive or negative infinity, this is just going to act like a line with a positive slope. Maybe it does something weird here in the middle, like, I don't know, bouncing around or something, maybe some vertical asymptotes. But as we go off towards infinity, for x, or negative infinity, it's going to look like a line. Okay, so what do these y values do for part B and C? For part B, x going to negative infinity, y is going to go to negative infinity as well, because that's what a line with a positive slope does. And as x goes to positive infinity, moving to the right, y is going to go to positive infinity as well, because that's what a line with a positive slope does. Okay, I hope it makes sense to you guys, and I'll see you in another video.